Usually foliage in games is not interactive. That means that you cannot rotate the actual meshes and that you cannot interact with them. But in today's tutorial we are going to learn how to create interactive foliage based on particles and the player's position. So the only two things that are special in my project right now is this grass mesh and the texture, actually the material on it. But they are not that special yet. We will need to customize this material a little bit later using the world position offset to bend the grass, so to make it interactive. But until then we will need to create a new material parameter collection. So to do that, let's go into content, right click, materials and textures, material parameter collection, and in here I'm going to call this MPC underline grass. And here we will need to create a scalar parameter and a vector parameter. So let's name the scalar parameter, so capture size, and the other one capture location. Okay, and we don't need to change the default values. We are going to use this a little bit later in our grass material, but until then we will need to create two new materials. So the first one is going to be called M underline direction, and then another one called M underline background. Okay, so now let's see how we can set this up. Let's start with the M background material because this is the easiest. So let's just go in the main material node, set this to be unlit, and from emissive color we are going to get a constant tree vector and set the red and green to be 0.5. So we are going to get this dark yellow color. Okay, let's save and let's go into the M direction material. Here things are going to be a little bit more complicated, so just follow me. Go to blend mode, translucent, because we are going to have some parts fading out, so we want to be able to access the opacity node. Then go to shading model, and from default lit, set this to be unlit. Okay, and now from emissive color we are going to get texture coordinate. We are going to subtract 0.5. Then we are going to normalize this. Okay, and then we are going to need to multiply this with 0.5 once again. And the last thing that we have to do is to add 0.5, then plug this in the emissive color. Okay, so now if I'm going to go in the plane view, you're going to see this gradient color. So from red to yellow to green. But the thing is that we don't want this to be a square. So we are going to access the opacity pin and we are going to set this up. So what we'll get here is radial gradient exponential. Okay, and then I'm going to multiply this with a particle color. Okay, but we need to get the last pin, so the alpha pin, and then plug this in the opacity, and now we're going to see a circle with the same colors. Okay, so now we set these two materials up. We'll go on and setting up something else that we need before setting the material for our grass to bend. So the next thing that we are going to create is going to be an actor which is going to capture where we want and how we want to bend the grass. And we're going to use render targets to do that. So what we'll need to create now is a new render target by going to content browser, materials and textures, canvas render target, and I'm going to call this render target underline grass. Let's open it and set the size X and size Y to be 512 by 512. Now let's save, and now we'll need to create a new blueprint. So right click, blueprint class, a new actor, and I'm going to call this VP underline capture actor. Okay, and now what we'll have to do here is to add a new scene capture component 2D, and what we can do to this is to add a new arrow. So add arrow. So now we can see in which direction our scene capture component aims. But this is not the right direction it has to aim. What we'll have to do is to go into the scene capture component, go to rotation, and let's see how we can rotate this to suit our needs. So we'll need to rotate the Y, let's see, 90. So right now this is going to aim upwards, but this is not what we want. Once again, we want this to aim at the ground from above the landscape, let's say. So we are going to need to put here minus 90. And also on the Z-axis we can put 90. And now we'll need to go to texture target. In here we will need to drag our new created render target. So just plug this in here. And let's change the projection. So from perspective, we are going to change this to orthographic. And we are going to set the ortho width to be 1024. And you can change this value, but going too high is going to create some bugs and possibly artifacts. So you can play with this value and see which is going to suit your game the best, and see how much you can go without getting any bugs. And I'm going to show you later why this value is important. Okay, so now the only thing that we have to change is to go to primitive render mode, and instead of this default value, we'll need to go to use show only list. This is going to make sure that we can set a list of actors we want to draw to this target. So not everything is going to be drawn, such as, let's say, trees or buildings or other meshes. So we are going to set that a little bit later once we create everything we need. So now we will need to play a little bit in the event graph. What we'll have to do is to get here a set scalar parameter value, and now we are going to set one parameter that we created in the NPC grass collection, and it is going to be the capture size. And the capture size should always be the ortho width of our scene capture component 2D. So get ortho width and plug this in here. Okay, and then we will need to set here a timer by function name. So set timer by function name, which is going to update every 0.01 seconds the location of our BP capture actor. So let's add custom event, move target, and I'm going to paste this in the function name. And now this function, this custom event is going to be called every 0.01 seconds. And what we have to do here is to set actor location. And we only need to set the X and the Y location. We don't want to set the Z to be something else. So I'm going to get actor location, and every time we are going to set it to be the same Z axis, Z value. Okay, and the X and Y will need to be our player's character. So get player character, then get actor location, and then let's split this as well. Plug the X in the X and the Y in the Y. And now we also need to set the vector parameter from our NPC grass collection. So set vector parameter value, collection NPC grass, parameter name capture location, and then we will need to get actor location, and the target is going to be self. And then we are going to set the parameter value to be the return value. So just try to plug these and it is going to automatically convert to be a linear color structure, as you can see here. Okay, let's compile, and now I think we are almost done with the BP capture actor. We are going to set the show list, as I said, a little bit later though. Okay, and now the next thing we have to do is to create a new particle system. So let's go to content browser, right click, and a new particle system. Let's call this PS underline grass effector, and let's get into it. So the first thing that we have to do is go to required, and here set the material to be the one called M underline direction. So just plug this in here. And the other thing that we have to do is to go to sort mode. Here we will need to go and set it to be P sort mode age newest first. So those that are the new particles are going to be in front of the ones that are older. Then the next thing we have to do is to go to initial velocity, and we can just delete this node. Initial size, we can go here and set the distribution to be distribution vector constant, and set this to be 150, 150 and 0. Then we can go to lifetime, and here once again distribution float constant, and the constant should be 5. Then we will need to go to create a new module, go to orientation and lock axis, and now we will need to go to lock axis flags and set this to be the Z axis. So now this is only going to face upwards towards the render target. And then we also need to go to rotation, initial rotation, and then set this to be a float constant, and set this to be minus 0.25. Okay, so that is going to fix a bug that we are going to encounter if we would not do this. So now that we are done with our particle system, we'll need to go into our third-person character, or whatever character you have, doesn't really matter. Then go in the viewport and we are going to add some new components. One of those is going to be a particle system, and the particle system is going to be the one that we just created. So template, plug that in here, and then let's go a little bit to details and search for owner. No, see, we don't want our player to be able to see these particles. Then we're also going to add a plane as a component, and then we need to set the location of this to be minus 5000 on the z-axis, and scale should be 100 and 100 by x and y. And the material is going to be the M background material, which is going to blend nicely with this yellow that we got here. Okay, so now that we have these components, we will need to see how our render target is going to make the difference between actors that we want to capture and components, and actors and components that we don't want to capture. So to do that, as I said, we are going to use this show only list. And to add components to this, we are going to need to drag our scene component and then component show only list. And if you are going to read the description, add the component to our list of show only components. But now let's see, how do we know which components we want to see? So from setTimer by function name, we are going to get all actors with tag, and the tag is going to be grass effector. Then from out actors, we are going to make a for each loop. Okay, so now we are going to get all the actors which have this tag in our world. And from here we are going to get array element and then get components by tag. And the tag is going to be once again grass effector. And the component class is going to be primitive component. So we are going to get all the actors with this tag. If we found any, we are going to search if that actor has any components with this tag, grass effector, and if it does, we are going to add each of them to the array element, to the show only component, by adding the array element in the in component. Okay, but currently we don't have any components with grass effector tag, so I'm going to copy this now and then go into my third person character. In here we need to go to our third person character and get tags, and here set these tags to be grass effector, then go to particle system, create a new one, grass effector, and then go to the plane and create another one, and then this one is going to be grass effector. And something that we can do right now is to create a widget blueprint. Doesn't really matter how we call this. Okay, so render target, and we can add here an image, and the image is going to be our render target grass. Make the size to be nice and big. Okay. And now we can see if this is working or not. But we also have to draw this to the third person character. Okay, so create widget. Okay, RT, and then add to viewport. And let's see. So currently it's not showing anything, and that is because we haven't set the BP capture actor in our world. So all you have to do is to set the location to 0, both X and Y, and the Z should be 2000. Okay, let's see. So right now it's not showing anything, and that is because there's a problem with how it is shown on our widget. But if you're going to take a close look here, you can see that this is not black anymore, this is somewhat of a purple, and that is because it tried to capture something and it did capture something purple. But this is going to work perfectly fine once we set up our material for the grass. So let's see how to set that up now. But before bending the grass, we will need to create two material functions. So content browser, materials and textures, and two material functions. The first one is going to be mf underline mask UV, and then the next one is going to be mf underline projection. Okay, and now in the mask UV, what we'll have to do is to get a function input and get function input vector 2, input name UV, and then get a custom node. Okay, plug this in the output result, and in here in the custom node we need to set the output type to be float1, input name UV, and now we will need to write some code. So what we'll have to do here is an if statement. If uv.x is smaller than 1, or if uv.x is bigger than 1, or if uv.y is less than 1, or if uv.y is bigger than 1, we are going to return 0. Okay, and if none of these are true, we are going to return 1. Okay, and make sure that we don't forget the semicolon. Let's save it now. Let's get into the other material function. Then here in our material function, I'm going to get world position, and then I'm going to mask red and green. Then I'm going to get a collection, so collection parameter, mpc underline grass, and it's going to be capture location. Then I'm going to copy this mask, and then I'm going to subtract these two. So subtract. Then we will need to add to this another value that is going to be the capture size divided by 2, and then add this in here. Then we're going to divide this by the capture size, and that should be plugged in the output result. And now we are done with this. The only thing that is left to do is to customize this grass material to bend. So let's see how to do that. So what I'm going to do right now is some complex material stuff. So if you don't know what this is going to do, try to follow along and copy the code, and then try to go into the documentation and learn what each node does. I'm also not the best when it comes to materials and explaining them, but I'm going to try my best to explain so everybody can understand. So from here, I'm going to get a material function, and this is going to be material function projection. Then I'm going to get another one, and this one is going to be mask UV. Let's plug this in here, and then as well from result, I'm going to get a texture sample. This texture sample is going to be the render target grass. And then from the first pin, I'm going to get here a mask component, which is going to mask the red and green channels. Then I'm going to multiply this by 2. And then I'm going to subtract 1 from this. So subtract. And then here we're going to need to do two things. The first one is to get an append node, and the b should be a constant one with a value 0. So now, taking into account that we masked the R and green channels, we got here a vector 2, and then because we appended with a 0, now we have a vector 3, which means that this is going to have 3 channels, this append node. Then here I'm going to do a cross product, and the b is going to be a constant 3 vector with the values 0, 0, and -1. Okay. Then, as well from this subtraction, I'm going to get vector length. Okay, let me drag this to the left. From vector length 2, I'm going to get here multiply. And the b is going to be a parameter. I'm going to call this max rotation. Okay, let me spell this correctly. So max rotation. And the default value is going to be 0.2. This is going to go into the B node. And the next thing is going to get the absolute world position. So here, world position. And from here, I'm going to get a multiply node as well. So multiply. Then I'm going to get another constant 3 vector, which is going to be the exact same one as this one. So copy it and paste. Then I'm going to transform vector. So this one. Okay. And we need to change this from world space to local space. Okay. And actually we need to go to the source and set this to be local and destination to be world space. Okay, then I'm going to multiply this with another parameter, and I'm going to call this pivot. So pivot offset. And the default value is going to be 80. Now plug this in the B node, and we need to multiply this. Actually, we don't need to multiply this, we actually need to subtract them. So basically we are going to subtract 2 vector 3s. which is going to subtract from the absolute world position. We're going to get the local position, local space. Okay, and now we'll need to get a rotate about axis. And now the normalized rotation axis is going to be this one. The rotation angle is going to be this one. The pivot point is going to be the subtraction, and the position is going to be the absolute world position. Now it's time to add the last three nodes. The first one is going to be a vertex color. We are going to multiply the red channel with the rotate about axis. Then we are going to multiply this with the MF mask UV. Plug this into the world position offset. Let's save and let's see if this is working or not. And if we have any problems, of course. Okay, now let's wait until this saves. Might take a while. Okay, it's done, and now let's play and let's see. So as you can see, it is working, but there's a really weird bug. And it seems that our enter target is moving in a weird way. So in order to fix that, we'll need to go to our capture actor, go to scene capture component 2D, and instead of having here 90, we will need to have minus 90. Okay, now let's play and let's see if this is working or not. So as you can see, it is indeed working. Now you can interact with the grass. But if I'm going to go a longer distance, you're going to be able to see that the grass is going to disappear behind me. And that is because of our BP capture actor. If we are going to make the ortho width to be, let's say, 1024 multiplied by 4 and multiplied by 2 once again, so that means 8, you're going to see it is going to take some time until it disappears, right? But there's going to be a problem with this grass that is going to shake a little bit. So as I said, try to play with these numbers, see which is going to suit you and which are going to give the best results, and just try, experiment. There's no other way to see the perfect value. And so this is pretty much everything for today's video. I hope that you enjoyed it, and if you did, don't forget to leave a thumbs up, and if you're new to the channel, don't forget to subscribe to the Alpha team for new videos. I want to get more into materials and particles myself and make tutorials on this as well, because I see that people are really interested in this. So let me know in the comments below which do you want to see more often, materials or particles. Also, don't forget that this tutorial was inspired by an article, and you can go over on the link that I'll leave in the description and download the project files if you want to see how this was created without recreating it yourself. That being said, thanks for watching, and I'm going to catch you in the next one. Goodbye.